2018, number 4, part A, they ask us to estimate h prime of 6. So, and they've given us a table of values. This is another very common one, something they like to do. You find an average rate of change and use that average rate of change as an estimate for h prime of 6. So they're asking h prime of 6, so we're going to use the t values of 5 and 7 because 6 is in between 5 and 7, and 6 is not one of the values that they gave us. If this were a value of 6 right here, we would use the 3 and the 7, the values on either side. But since they gave us a value that's not on the table, we just take whatever's on either side of them. All right, so we're going to use essentially what we're going to do is we're going to use the average rate of change. This is approximately equal to the average rate of change, f of b minus f of a over b minus a, for the slope formula. We're going to use that as an estimate for the instantaneous rate of change. All right, so that h of 7 minus h of 5 is going to be 11 minus 6. So most people got this, so I don't want to belabor it too much, over 7 minus 5. So, and we could just leave it there if we didn't have to interpret it, and then because the interpretation sentence gets awkward if you have to put this huge fraction in it. So it's not too hard to just call it 5 over 2. All right, and then you want to refer to the context of the problem, right? When it says in the context of the problem, make sure you're referring to a tree and the height of the tree. So we want to say the tree grows at a rate of, and we should say approximately 5 over 2 meters per year. So that's just using, our units from here. We have h prime, which is dh dt, so it's meters per year, at t equals 6 years. So we're using an average rate of change to approximate an instantaneous rate of change. So at that time, it's growing at an instantaneous rate of change of 5/2, but that instantaneous rate of change is only an approximation, so approximately 5 over 2 meters per year.